Tanks are the behemoths of the battlefield, towering over other vehicles with their sheer size and power. They are the decisive factor in ground warfare, often turning the tide of battle with their presence. Their massive firepower and tactical mobility give them a dominant role, allowing them to strike hard and move swiftly. But to achieve victory, tanks need protection, as they are prime targets for enemy fire. This is where armor comes in, acting as the first line of defense. Tank armor is its shield, safeguarding it from enemy fire and ensuring its survival on the battlefield. From the first lumbering tanks of World War I to the sophisticated machines of today, armor has been a crucial element of tank design, evolving with each generation. The evolution of tank armor is a fascinating story, reflecting advancements in technology and changes in warfare tactics. It's a constant race between offensive weapons and defensive measures, each trying to outdo the other. As weapons became more powerful, tank armor had to keep pace, adapting to new threats. Early tanks relied on thick plates of steel, which provided basic protection, but had significant limitations. This provided basic protection, but came with limitations such as weight and mobility issues. Modern tanks utilize a combination of materials and technologies. These include composite armor, reactive armor, and active protection systems, each offering unique advantages. This evolution reflects the constant need to outmaneuver the enemy in the lethal game of armored warfare, where survival depends on innovation. The effectiveness of a tank's armor can mean the difference between a successful mission and a catastrophic failure, impacting the outcome of entire battles. It ensures the crew's survival and allows the tank to continue fighting, maintaining its operational capability. The history of tank warfare is filled with examples of well-armored tanks proving their worth in combat, standing as testaments to the importance of armor. Understanding the evolution of tank armor is key to understanding the evolution of warfare itself, as each advancement in armor technology has shaped the strategies and outcomes of conflicts throughout history. In the early days of tank warfare, the solution for protection seemed straightforward. Thicker steel meant better protection. The idea was simple: the more steel you had, the harder it was for enemy fire to penetrate. Rolled homogeneous armor, as its name suggests, was the go-to choice. This type of armor was favored for its simplicity and effectiveness. It was made by rolling large pieces of steel into uniform plates. This process ensured that the steel had consistent properties throughout. These plates were then cut and welded onto the tank's chassis and turret. The assembly process was labor-intensive but crucial for the tank's durability. RHA was simple to produce, relatively inexpensive and readily available. Its production could be scaled up quickly to meet wartime demands. Its uniformity made it consistent in its protective qualities. This consistency was vital for the reliability of the tanks in battle. Tanks like the American M4 Sherman and the Soviet T-34, both iconic machines of World War II, relied heavily on RHA. These tanks became symbols of their respective nations' military might. These tanks engaged in fierce armored clashes across the battlefields of Europe and North Africa. Their battles were legendary and often determined the outcome of key engagements. However, the limitations of RHA became increasingly apparent as anti-tank weaponry advanced. The once reliable armor started to show its weaknesses. High-velocity projectiles, such as those fired from anti-tank guns, could easily penetrate even thick plates of RHA. This vulnerability was a significant concern for tank crews. This highlighted the need for more sophisticated forms of protection. Engineers and scientists began to explore new materials and technologies. While RHA provided a good starting point, it was clear that the future of tank armor lay in exploring new materials and designs. Innovations were on the horizon. The arms race between armor and penetration had begun. Each side sought to outdo the other in a continuous cycle of innovation. RHA, though effective in its time, would soon pave the way for more advanced forms of protection. The evolution of tank armor was just beginning, setting the stage for future advancements. The quest for more effective armor led to the development of composite armor. This marked a significant departure from the homogeneous nature of RHA. Composite armor combined different materials, each with its own unique properties, to defeat incoming projectiles. A typical composite armor array might include layers of steel, ceramics, plastics, and even air gaps. The idea was to create a multi-layered defense that could disrupt the penetration capabilities of different types of projectiles. Each layer in composite armor plays a specific crucial role. Steel provides strength and rigidity to the overall structure. Ceramics, with their extreme hardness, can shatter the penetrator upon impact. Plastics and air gaps can help to absorb the shock waves and fragments, further reducing the effectiveness of the attack. Tanks like the American M1 Abrams and the German Leopard 2 are prime examples of tanks that utilize composite armor. This advanced armor technology has proven highly effective against a variety of threats, including high-explosive anti-tank rounds and kinetic energy penetrators. The exact composition and arrangement of these materials are often closely guarded secrets, as they are critical to a tank's survivability on the battlefield. Section 4. Fighting fire with fire reactive armor enters the fray. The development of shaped charge warheads, which use explosives to form a high-velocity jet of molten metal, posed a significant challenge to tank armor. These warheads were designed to penetrate even the thickest armor, making traditional tank defenses increasingly vulnerable. To counter this formidable threat, a new type of armor emerged: reactive armor. This innovation marked a significant leap in defensive technology. Reactive armor, as its name suggests, actively reacts to an incoming projectile to defeat it. This dynamic response is what sets it apart from conventional passive armor. This type of armor typically consists of explosive-filled containers sandwiched between two metal plates. These containers are strategically placed to maximize their defensive capabilities. When a shaped charged jet strikes the armor, the explosive detonates. This controlled explosion is a critical component of the armor's effectiveness. This detonation propels the metal plates outward, disrupting the jet's formation and significantly reducing its penetration capability. The outward movement of the plates effectively neutralizes the threat. Reactive armor was a game changer when it was first introduced. It revolutionized tank defense strategies and provided a new layer of protection. It provided a relatively lightweight and cost-effective way to enhance the survivability of tanks, especially against shaped charge warheads. This made it an attractive option for many military forces. The Soviet Union was a pioneer in reactive armor technology. They were among the first to recognize its potential and implement it on a large scale. Many of its tanks, including the T-72, T-80 and T-90, are equipped with various types of reactive armor. These tanks became symbols of advanced military engineering. However, reactive armor also has its limitations. Its explosive nature can be a double-edged sword. The explosive nature of its operation means that it can pose a hazard to nearby infantry or friendly vehicles. This risk must be carefully managed in combat situations. Additionally, reactive armor is often effective for only a single hit in a particular location. After detonation, the armor in that spot is compromised. Multiple hits in the same spot can overwhelm its protective capabilities. This vulnerability requires continuous innovation and adaptation in armor technology. Section 5. The Chobham Secret, a British breakthrough. In the realm of tank armor, few names carry the weight and mystique of Chobham armor. Developed in the United Kingdom in the 1960s, Chobham armor represented a significant leap forward in composite armor technology. While the exact composition of Chobham armor remains classified, it is believed to be a multi-layered composite incorporating steel, ceramics, and other materials in a specific arrangement. This combination is designed to defeat a wide range of threats, including kinetic energy penetrators and shaped charge warheads. Chobham armor is renowned for its exceptional strength-to-weight ratio. It provides excellent protection without overly burdening the tank's weight or mobility. The introduction of Chobham armor marked a turning point in tank design. The British Challenger 1 and Challenger 2. Main battle tanks are prime examples of tanks equipped with Chobham armor. The effectiveness of Chobham armor has been demonstrated on numerous occasions in combat and testing. It has proven to be a highly resilient form of protection, earning a reputation as one of the most advanced types of tank armor ever developed.